This is number 2. We're going to do A and B. So solve the system algebraically. We have 3 equations here with 3 variables. First step is to try to eliminate one of the variables. You can combine a pair of equations. So for example, you can combine the first 2. I'm going to try to get rid of y, but you could try to get rid of x or z as well. We need to multiply the second equation by 2 in order to cancel things out. So that's going to become 4x minus 2y plus 2z equals 4. So again, I multiplied that by 2. Combining those is 5x plus 7z equals 3. So now I have an equation that has x and z. That means I need another equation that also has x and z so I can solve a system of 2 equations. So find another pair of equations. So for example, you could use the second and third equation, or the first and the third equation. So if you decide to use the second and third equation, the second one would now need to get multiplied by 4. 8x minus 4y plus 4z equals 8. 3x plus 4y minus 4z equals 14. Adding those together gives us 11x. Notice the y's cancel out and the z's cancel out. That's kind of nice because now I can actually solve for x. X equals 2. So originally I said we need another equation that has x and z. Well, this is even better because I already know what x is. Now I can plug it back into here. 5x plus 7z equals 3. 7z equals 3 minus 10, which is negative 7, so z equals negative 1. Now I know x and I know z. I need to find y, so take any original equation and plug these in. I'm just going to use this one at the top, so x plus 2y plus 5z should equal negative 1. So 2y equals 2 minus 5 is negative 3. Add it to the other side, and that's 2. So y equals 1. So as a point, x, y, z, it would be 2, 1, negative 1. All right, part B. Again, we want to try to eliminate a variable. So it looks like z is already ready to get eliminated here. So I'm going to add the first 2 equations together. Negative x plus 2y equals 8. Now I need another equation that has x and y. So I'm going to combine the second 2, but I need to multiply the second one by positive 4. So that would be negative 8x plus 4y plus 4z equals 12. This equation we can just rewrite. Canceling those gives us negative 4x plus 8y equals 32. So now I have 2 equations and 2 unknowns. I'm going to combine those and pick a variable to cancel. So if I'm trying to cancel x, I'm going to multiply this equation by 4, or actually by negative 4 because I want it to cancel. So that would become positive 4x minus 8y equals negative 32. Now adding these two, 0 and 0 equals 0. That is a true statement, 0 equals 0, but I was not able to solve for x or y. This tells us that this system has an infinite number of solutions. You don't want to write all real numbers because these are points. The solutions are points, not just numbers, so it's an infinite number of solutions.